Hi, welcome to Turkish Engineering. In this lecture, we are going to study chapter 4, which is Newton's laws of motion. As we mentioned in the previous video, we finished chapter 3, which was the kinematics of translational motion in 2 dimensions. In this video, we are going to take kinetics of translational motion in 2 dimensions. So, in chapter 4, we will see the first part of kinetics, which is the force. So, the force will be the first part of the kinetics, and the second part will be energy, and the last part will be momentum. So, in the kinetics, we can talk about 3 things: the force, and the energy, and the momentum. So, let's start by forces. The force is the push or pull on an object with mass causes it to change its velocity. Actually, the change in velocity will come from acceleration. So, force will cause to an acceleration. So, force is an external agent capable of changing a body state of rest or motion. So, if the body is at rest, I can change its state from rest to the motion by applying a net force on the object. So, if it's at rest, it will need a force to move. Or if it's moving in uniform velocity and in just certain direction, to change its direction, I will need a force. Just like driving a car, when you are going with a straight line, so if you want to just turn left, you will need to push. You will just need to apply a force which make your car moves to the left side or the right side. So force will change body state from rest or from motion to the other state. And it has a magnitude and direction. That means the forces are vectors. The forces are vectors because they have both magnitude and direction. So, let's take some types of forces. Actually, the normal force, which will come from the ground, when you are applying a weight to the ground by your weight, you are pushing down. So, why you are not accelerating down? There is force, but you are not accelerating. Because there will be a normal force which is acting above, acting on your object to the upward, that will balance your weight, so you will not accelerate. And normal force will be always perpendicular to the surface. So as you see here, surface is inclined, so the normal force will be just as you see here. The surface is rotated by this degree, so the same amount of degree your normal force will be rotated. We have friction force, which will come from the friction between atoms of the object and the surface. And we will study more about friction force in chapter 5. And the normal force also will be studied in chapter 5 in more details. We have a tension force, which is coming from in the elastic objects. When you are applying a force and pulling, so you will have a tension force, just like a rope or cable or cord. The pull of gravity on an object will be just a weight. Okay, so in this space there is no weight, but you have a mass. Your mass will not change, but your weight will change from the Earth to the moon. So in the Earth, you will weigh more than what you weigh in the moon, because the gravitational acceleration which is pulling you down will be just proportional to your weight. More the Earth pulling you down, more you feel your weight. So more your weight will be. Actually, in the moon, because of mass of the moon less than the mass of the Earth, the moon will pull you, but slightly smaller than the Earth pull. So you will see that your weight will be smaller in the moon. So this is push and this is pull, 2 types of forces. Okay, the force will be just push or a pull. And this is gravity, which is acting on the free falling object, so it is falling down with a force, and this force is its weight. But actually, the forces will not be enough for studying motion. Now we are talking about the causes of the motion. So, can a force be enough for cause for acceleration? Actually will not be enough. Why? When I'm pushing in this direction with 10 Newton and my friend applying the opposite force against me with 10 Newton, so let's say that I want to move the table which is in front of me with 10 Newton, and I have a friend which is opposite side of the table will push against me. I will push 10 Newton and he will push 10 Newton. So I will see that because there is a balanced force which these forces are balancing each other. So the net force will be equal to 0. If there is no net force, so you can say that actually there is no acceleration, because the acceleration will be proportional to the net force and not the force. So force will not be enough. But how can we study net forces? Actually, resultant of forces, of net forces, just the summation of the all forces in that axis. Okay. So as you see here, resultant of forces in the x-axis will be sigma fx. And sigma is a Greek letter, means the summation. So summation of all fx. That means fx1, actually the f1, which is the first force which is acting on the body in the x direction, plus f2, which is the second force in the x direction, and the third force, like this. So when you add all forces which are acting on the x-axis, so you will get the resultant force in the x. That means the net force in the x. What about the resultant force in the y? When you add all forces which are acting on the y-axis, so you will get the summation of the all forces in the y. That means resultant force in the y. So as you have two directions, as you have two components of the resultant force in x and in y, so you will have a resultant. This is hypotenuse. So how can I calculate for hypotenuse? Actually, you will take square root of x component squared plus y component squared, as you just make it for any vector. So in acceleration we apply this, in displacement we apply this rule, in the velocity actually we apply the same rule, and in the forces we will apply the same rule, because they are all vectors. So this is the rule which is coming from trigonometry, or you can say geometry, and we will apply this for the vectors. What about the theta? So we will have an angle between, so if you have an inclined force which will be in this in an angle with an angle, and this angle is bigger than 0 or smaller than 0, it is not 0, so you will have two components. But if it's 0, you will have only x component, or if it's 90 degree or 270 degree, that means only you have y component. But how can you calculate this angle? Actually, this formula will give you this angle for all cases. If you have 0 degree, you will put fy divided by fx will give you 0 degree. If you have just 90 degree, this formula will give you 90 degree. So for each cases, this formula will be applicable. So inverse tangent of fy divided by fx will give you the angle, and this coming from geometry, and we explained why we use this formula in the velocity section in the previous chapter. So as you can apply this rule for f and for the f force, actually this is individual forces, the one of the forces. So you can take this rule and apply it for any force, and also for the net force. So our net force, same as the individual forces, is a vector. So you can apply the same rule for this one. But this theta, which is between ry and rx, will not be equal to this one, fy fx, in the most of cases, because you have different f's, and all f has different angle, and the resultant x, which will be the summation of all vectors, all force vectors, will give you another angle. And when we apply some examples, you will understand more. And how can we calculate the resultant of any force? Actually, this means the total force. You have two components, x and y. How can I calculate the resultant of them? So we will use this formula, which is coming from geometry, and this is the Pythagorean theorem. if you want to take just one component of your vector, you will, for example, let's say I want to calculate my x component. So I have a force which will be like this. So if you want to calculate your x component, which will be this one, or if you want to calculate your y component and you have an angle theta, so because of your x is adjacent, so you will use cosine theta. When you multiply this one by cosine theta, you will get the x component, and when you multiply this one by the sine of theta, because of the opposite side will be just the y, so you will get the F, which is the force in y direction. So it's all for the net forces and the forces, and this is chapter 4.1. Okay, chapter 4.1. So we will solve 3 problems to just finish this section. So how can we apply net force in this example? Actually, find the tension in each cable. How can I calculate it? Actually, in this point, they are in equilibrium. Okay, so net force in this point must be equal to 0. Actually, I will show why it must be equal to 0 in the next videos. So you will take Newton's laws of motion, so you will understand why they are equal to 0. But let's say in the question it is given that net force must be equal to 0. So how can you calculate the tensions? Actually, in this point, when the whole system is in equilibrium, so any point, when you are taking any point, these points must be in equilibrium. So I will take the spatial point, which will include 3 tension forces. So when you take this point, you will get 3 tensions: tension 1, tension 2, and tension 3. So actually, the bird food here will be just 150 Newton. So the tension in 3 is given. Actually, that must be equal to this one to carry the load of the bird food. So must be equal to this one. It is given in the question. But how can I solve for T2 and T1? So I will just apply my net force rules to solve this question. I have T1 here in this direction. If you have here 30 degree, from the Z rule, you will have here 30 degree because it is between the horizontal and this line, and this angle which is here also between the horizontal and the same direction. So here you have just 30 degree. And you have a second vector, which is the tension vector, tension 2. This is tension 1 and tension 2 here. And tension 1 is down. Okay, tension 1. So, and this is you have 90 degree here, which is negative 90. So you have between this one, between the horizontal and this one, you have 90 degree, actually 60 degree. So this angle, which will be between the horizontal and this line, must be equal to 60. So how can we calculate the components of these tensions? So I will say that resultant of the x must be equal to 0, because I'm saying that the net force is equal to 0. So in each directions, in x and y, they must be equal to 0. So Rx must be equal to 0 and Ry must be equal to 0. But how can I get these? Rx, which is summation of all forces in x, will be equal to T1x plus T2x plus T3x. So let's calculate T1x. Actually, T1x will be equal to T1 cosine theta. And as you know, T1 is 150 degree, 50 Newton. But what about the cosine? Our angle here is going clockwise direction, so it will be negative. If you are going up in counterclockwise, that means you have positive angle. But here I have negative angle, so I will put minus 90. So let's see what's our solution. 150 multiplied by cosine of negative 90 will give me 0. Actually, as you see here, it is just in a vertical, so there is no x component. So it is easy. What about T2x? T2x will be equal to T2 multiplied by cosine of this angle. But I will not take this angle because my initial point must be started from positive x-axis. So I will start from here to reach there. So my angle for T2, which is theta 2, must be, and this is theta 1, which is negative 90 degree, and this is theta 1, which is just 30 degree from the positive x to the T1, and from the positive x to the T2, which is tension 2, will be just 90 plus this one, or 180 minus this one. Actually 90 plus 30 will give me this one, or 180 minus 60 will give me this angle. So I will put here this angle. And what about T3x? Actually T1, I put this is T3. Actually this is T3. So, and this will be angle 3. And here, actually this one is T3x, and this one is T3. Okay, so, and this is cosine 3. What about T1x? It will be T1 cosine of theta 1, and actually it will be T1 cosine 30. Okay, so if Rx equals to 0, so summation of all forces must be equal to 0 because of the equilibrium case. I will explain why in the next sections, but just take this, these are equals to 0, okay? In this section, we are just taking the idea for calculating net forces, okay? So, Rx must be equal to 0. So, how many forces I have? 3 forces, but one of them is 0. So, I have only T2 cosine of 120 plus T1 cosine 30. Actually, one of them will be negative sign and the other one positive, so they will balance each other and the resultant of them will be equal to 0. Now let's move to the y-axis. Actually, y-axis will give me some numbers, and in this square equation I don't have any numbers, so I cannot calculate for T2 or T1. What about Ry? In y-axis I have 3 forces, which is the tension 1 y and tension 2 y and tension 3 y, their components in the y direction. How can I calculate T1 y? It will be just T1 sine of theta 1. So T1 sine of 30, because our first angle, which is this one, by 30 degree angle. So I will put like this. What about T2y? The second angle here is just 120, so it will be 120 sine of 120 times sine T2 times sine 120. And T3y will be equal to T3 sine theta 3 will be equal to, I know T3 because T3 is given, it's just the weight of the bird feeder and 150. So 150 multiplied by sine theta 3, and sine theta 3 is actually minus 90, so I will put here minus 90 to get the solution. I will get negative 190 Newton. As you see here, actually I have just 150, which is just down in a vertical, so I must have negative quantity. This is the magnitude, and here I got the direction of y component. Okay, so I will put 0 must be equal to T1y, which is T1 sine theta, and this is actually equal to T1 over 2, which is half of T1. Half of T1 plus T2 sine 120 T2, just take sine of 120, will be equal to 0.766. 0.766. So 866. 0.866 T2 I have here from here, and I have minus this one. they must be equal to 0. So here I have two unknowns and one equation, and here I have two unknowns and one equation from this one. So I will solve for two unknowns by using two equations. So let me just solve for this. Actually, one of the equations, I have two equations as you see here. Okay, I will start by this one to see what's the relation between T2 and T1. I must reduce my unknowns to 1. I have two unknowns and two equations. By using one of the equations, I can reduce my unknowns from 2 to 1. So I can put T2 in terms of T1. So T2 will be equal to minus T1 cosine 30 divided by cosine of this one, right? So when you see T2, you can put this value. From this equation, I send this one to other side, so it has minus. Then divide both sides by this, so I got this one. So when I see T2, I can put minus T1 cosine 30 divided by cosine 120. So in the second equation, which is this one, when I see T2, I will put the other one. So 0 will be equal to T1 divided by 2 plus 0.866 multiplied by T2, which is equal to this one, right? So minus T1 cosine 30 divided by cosine 120 plus T, which one? Minus this one. So I have only one unknown here. To just simplify this one, these, and these, I will use my calculator. So actually cosine of this one will be equal to just minus 0.5 minus 0. Actually, I will take 0.866 multiplied by cosine 30 divided by cosine 120. And actually, I have minus up, so I will put minus. As you see, 1.5. So 0 will be equal to, actually this one is 0.5 T1, which is half. And here I have, it is negative because I have negative here. So actually no, negative this one, because of cosine, this cosine 120 will give me negative sign. So I will get positive. Negative divided by negative will give me positive. So I have here positive 1.5 T1, which is coming from this, minus this, they are equal to 0. So I have, when you send this one to other side by positive, so you will get 2 times T1 will be equal to 150. So you will see that T1 is equal to just 75, because you will divide both sides by 2, so you will get T1 is equal to 75. What about T2? How can solve for tension 2? Actually, now you are given that the third tension force is equal to 150, and the first tension force you calculated as 75. The unit is Newton, but you didn't calculate the last one, which is tension 2. So by using this equation, you will calculate the tension 2. So when you see tension 1, you can put the value which you calculated. Okay. So let me take. So I will erase T1 and I will put the value which I know, which I calculated. So I will get T2 will be equal to minus 75 multiplied by cosine 30 divided by cosine 120. So I will get 129.9, let's say 130 Newton. So now I know the second tension force and the first one, and actually the third one is given. So I finished the problem. Actually, I have two additional problems, which is this one, problem 2 for just net forces, and this one. But I will solve them after I finish chapter 4 lectures. So we will just study 6 parts of chapter 4. This is just the first part of chapter 4. So when we finish all the topics in this chapter, I will solve more additional problems, and these 2 problems you will see in the last video for chapter 4. So see you in the next video for studying Newton's laws of motion.